Good morning, friends. We are learning our subject, that is data mining. 3160714. And in that, we are learning chapter 3, that is concept description and rule mining. So, last time we have studied the basket data, and we now want to do the analysis of the basket data, and we want to give the rules of what the way the people are purchasing the items. Fine. Based on that, we can create the rules that people are purchasing this item, then they are purchasing this one also, right? And for that, we are having two measures. They are support and confidence, right? This is what we have talked of, right? But we just now do not know the definition of support and confidence also. That also we want to learn. Fine. So this is the market data, market basket data we are having, that we want to analyze and provide the rule using association rule mining. Fine. So how the data is given? Previous lecture, in that I have provided you the transaction data, like say one person is purchasing say bread, butter, wafer, right? So this way we have seen with the example. Now let us see that in the formal language, so we can understand both how to write the formal language and the example we have already seen. So this you can understand very easily. Fine. So what do we say is I is equal to I1, I2 up to IM, a set of items, transaction T, that is T, a set of items, okay? This is total set of items. That means say we are considering only 5 items, say bread, butter, kurkure, wafer and biscuit. So these are the 5 items which we want to consider. So that is the item set. Now here for transaction T, that is a set of items. That means for a particular person, a person is purchasing say bread, butter, kurkure. Second person is purchasing bread, butter, wafer, right? So that is, we can say T, transaction is a set of items, and that T is subset or equal to I. Transaction database T, that is a set of transactions, that is T is equal to T1, T2 up to Tn. Fine. Now transaction data of supermarket data. What we want to do is, we have already considered market basket data, right? So we are considering market basket transactions. So for that we can say, for say T1 transaction, bread, cheese, milk. For say T2, we can be having apple, eggs, salt, yogurt. For Tn transaction, we can be having biscuit, eggs, milk, right? So it depends on the supermarket. Whatever people have purchased from that, for them, we are having the transaction data, right? Okay. So now we want to learn the concepts, that is, we have seen a bit and some more concepts. Let us check it out. An item, that is an item or article in the basket. I, the set of all items sold in the store. A transaction, items purchased in a basket, it may have the TID, that is the transaction ID. A transactional data set, that is a set of transactions, right? Now, let's see the example. A text document data set. You can say we were talking of the market basket. Yes, market basket. About that, we have said this is the transaction. This is the item set. What items are available in that. Now, let us say we want to understand the transaction data, that is a set of documents. That example we want to see. So, for that, what we say is a text document data set. Each document is treated as a bag of keywords, right? So, say for example, for document 1, we are having student, teach, school. You can say, ma'am, teacher. You can have teach is for teaching, right? And teacher can also be there, right? What we are having in these documents, see, this is not the corpus where you are having this set of all the keywords. We are saying that these are the words, keywords which are available in this particular documents, fine. So say doc 1, student, teach, school. For doc 2, student, school. For doc 3, teach, school, city, game. Right. So what is that? That seven docs are given to us. If we say in the form of the concepts which we have seen just before, so there what we can do is we can have the I is this set of items. So from that we can say student, teach, school, then student, school we have already considered. Student, sorry, teach, school we have already considered. So we can have city, game, right? Let me show you that. Let me write it here so you can have the idea. If I want to have the item set for this one, I can say it is already given in the problem statement. Okay. I am showing you from these documents. Otherwise, always it is given to us, and if not given, then we can make it from the available transactions, right? So you can say here student, teach, school, all three we will put unique items from all these documents we will put in the item set. Fine. So it is here. Let me write in other line so you can see it clearly. Fine. Now teach and school, that is already available. Student and school, that is also already available in this item set. So let us consider city, game, right? So let us consider these two, put it in the item set, right? After that, what is the case? We'll consider the basketball, right? Let us consider, let us copy from here because here basketball is there. Okay, so we are adding it in this I. After that, what we are having is this player and spectator, both have come. Now, this coach, game is already there, right? So we'll have to exclude that. Why exclude? Because we are having the unique items, isn't it? In the item set. The transaction can have the same item repeatedly available. That is over here. You can say person has purchased basketball, then again purchase one more basketball. Fine. So that way we can write. What about the last item? It is, you can say here, let us put it here and then check it out whether it is having the unique items or not. Fine. Basketball was already considered, so let us remove it. Team, yes, it is there. City is always, yes, it is already considered. And game, that is also already considered. Fine. So we can say This is our item set. Fine. This is our item set. Fine. Let me put it at last. Fine. And let me put it a bit above for you. Okay. So you can see that. Still to make it visible, let us make it this way. Fine. So all the things are now visible to you and you can understand that also. Okay. So let us proceed further. Now, the model, the rules. Rules we want to create out of these transaction data. Fine. So how to make that? For that, a transaction T contains X, a set of items, that is item set in I, if X is less than or equal to, no, it is subset or equal to T. Fine. It is subset or equal to T. An association rule is an implication of the form X implies Y, where X, Y is subset of I and X intersection Y is equal to 5. Getting it? What do we say is X implies Y. For example, bread implies butter, where bread and butter, they are the subset of I, that is item set, isn't it? And bread intersection butter is equal to 5, right? Unique items. When we make the rule, we say that they are the unique item, right? It is nothing like X is containing some items, they are there in Y. No, it is not there because here the condition says X intersection Y is 5. Okay. So unique items, we are checking that we should have the rule say X implies Y, right? People will purchase X, they will purchase Y also, right? That's what we want to see, right? So an item set is a set of items that is known to us. X is equal to milk, bread, cereal, right? So for that, what do we say is an item set. A K item set is an item set with K items. K item set. That means the item set should consider K number of items. So for example, if I say milk, bread and cereal, that is 3 item set because it is having 1, 2 and 3 items. Okay. Now, rule strength measures. This is what we have talked of yesterday. That is, we are having the measures, their support and confidence. Now, let us see what they are and how we can find that. Okay. So, for that, the rule holds with support, that is written as SUP, in T transaction data if sup percentage, that is this one, support, percentage of transactions contain X union Y, right? If we can say the sup percentage of transaction contains X or Y. We'll see the example you can clear with this. What do we want to say is support. If I want to say that X implies Y, where can I accept this? For that, we should have support and confidence that rule should be satisfied. Which rule? That is whatever we say for support, whatever we say for confidence. That is, support is greater than or equal to some minimum support, and confidence, whatever we find, that is greater than or equal to minimum confidence. Now, for that, how to find that support and confidence? For that, we are saying that support is equal to probability of X union Y. Whatever transactions are there, in that we need to find the count where X and Y are available, right? What it says, X or Y. Fine. X or Y. So where X is there, that you need to count. Where Y is there, you need to count. Fine. Okay. So let us proceed further. For confidence, what do we see? The rule holds in T with confidence conf if conf percentage of transactions that contain X also contain Y. First was for, you can say, X union Y. Here what do we say is probability of Y where X is already there. Fine. Based on X we used to say, right? X is there and Y is there. Okay. An association rule is a pattern that states when X occurs, Y occurs with certain probability. Fine. So now, what are the formula for this? That is, we have seen this, right? What probability we require? That is, here we need to have the probability of X union Y. Here we need to have the probability of Y based on X, right? So now for that, we need to have the formula. So support count. The support count of an item X denoted by X dot count. That is, we need to find the count of that item in the data set. Fine. So in a data set, T is the number of transactions in T that contains X. Assume T has n transactions. So what do we say? That is, support is equal to X union Y dot count upon n. And what about the confidence? Confidence say that X union Y dot count. It is similar to that of this support for, for the above item. So what is there in the denominator? That is, we can say X dot count. Why here X dot count? That is, we are considering the rule X implies Y. For that, we need to write here X dot count. See, X implies Y is not equal to Y implies X. X implies Y is not equal to the reverse, that is Y implies X, because there here what we have to write, if X implies Y is there, here we have to write X dot count. If it is reverse, that is Y implies X, then here we need to write it as Y dot count. Fine. So X implies Y and Y implies X, both are not same. Okay. Now, what is the goal and what are the key features? Let us check it out for that. Find all rules that satisfy the user specified minimum support and minimum confidence. Find all the rules that satisfy minimum support and minimum confidence. You can say we are having the rule, that is this formula by which we can find support and confidence. So what is this minimum support and minimum confidence? That is being specified in the problem statement. If you say that the real world is there, over there the shop owner or whoever are the decision makers, they will say that this is the minimum support and this is the minimum confidence. Fine. So wherever the support and count, they are crossing the minimum support and minimum confidence, or you can say when the support and confidence, they are actually greater than or equal to minimum support and minimum confidence, we can say the rule, for example, x implies y is accepted. Fine. Now key features. One thing is completeness, that is, find all the rules. No target items on the right hand side. Mining with the data on hard disk, not in the memory. What do we mean to say by this? That is the mining with the data on hard disk, not in the memory. Typically, we say that whatever is there in the memory, that is say your cache memory or your RAM, over there we can see that whatever data is required, that is only there in your cache memory or in the RAM. But we say that the data on the hard disk, that means we are considering the whole transaction data. Okay. Now let us see the example. We can be clear with the idea that what is support and what is confidence. Okay. So a collection of one or more items, as for example, say milk, bread, jam. Milk, bread, jam. So it is 3 item set, isn't it? Because K item set is an item set that contains K items. So here we are having 1, 2, 3 items. So this set is called the 3 item set, isn't it? Okay. So now we want to find the support count. So frequency of occurrence in the item set, in the transactions. Let us say that we are having the item set wherein we are having milk and bread. So what is the support count of milk and bread? What we have to do is we need to find the transactions wherein milk union bread is there. Fine. Milk union bread is there. So where it is bread, milk. Yes, one is there, bread, milk. Second is there, then we can say here bread is there, here milk is there, here again milk and bread both are there, right? Milk and bread both are there. Fine. Together they are available. Here milk is there, here milk is there, here they are not there. Fine. So in all these transactions, we can say that the transactions where milk and bread both are available, the count available here is equal to 3. Fine. So support count of milk and bread is 3. Okay. Soda and chips. Soda and chips. Let us check it out where they are available together. See, order doesn't matter. Whether chips come first or soda come first, or soda is there, in between some items are there, then after chips is there, it doesn't matter. Order doesn't matter. Sequence doesn't matter to us. Only thing is both should be available and we should find the count of it. That is what is called as the support count. Fine. Okay. So now support count we are talking of. Okay. We are not talking of support. Support count is different and support is different. Fine. Okay. So support count we have found. Now soda and chips. Yeah. Soda here not. soda and chips. Yes, one it is available. Soda and chips. Okay, second time it is available. Soda is there, but yes, soda and chips. Three time it is available. For six transaction, we can say yes, soda and chips. So four times it is available. Now for seventh, no, it is not there. For eight, it is not there. Right? So we can say that support count of soda and chips, that is equal to 4. Fine. Now we want to find this support. Support is fraction of transactions that contain an item set. Fine. That contains an item set. That means what? Support count divided by total number of transactions. Okay. Support count divided by the total number of transactions. Okay. That is the support. So here we can say milk and bread. We have found that the support count of these two items is 3. So that's what we have written. What is the number of transactions available? They are total is 8. Fine. So we can say support of milk and bread is 3 by 8. Fine. Same way we can say for soda and chips, the support is 4 by 8. If we say support count, it is 4. But support, that is support count divided by number of transactions. So 4 divided by 8, right? So we can say it is 0.5. Okay. Now what is frequent item set? An item set whose support is greater than or equal to minimum support threshold. Item set is called frequent when the support of that is greater than or equal to the minimum support, right? Then we say that that particular item set is frequent. Fine. What is an association rule? Implication of the from x, y, that is x to y, where x and y are the item sets. For example, bread and milk. So what do we say? The rule, if we are saying, it is bread implies milk. Fine. It is bread implies milk. So rule evaluation matrix, they are the support and confidence. Support is fraction of transaction that contains both x and y, and confidence, it measures how often items in y appears in transaction that contains x. Fine. Support of bread and milk. If we want to find the support, we want to find the bread implies y. For that, we can say first of all we need to find the support, and second we need to find is confidence. Okay, so for support bread comma milk, what do we say? First of all, we need to find the support count. Here, better to write it as support count. So it will make your life simple, right? Otherwise, you may get the confusion. Okay. So what do we say is support dot count. Fine. That is 3 divided by number of transactions. That is 3 by 8, and it is support of bread and milk. Fine. It is the support of bread and milk, or you can say actually it is support for bread implies milk. Right. That is for this particular rule, support is 0.38. Fine. Now we want to find the confidence of the same rule. What is that rule? Bread implies milk. So for that, what do we need to do is support count of bread comma milk divided by support count of bread, isn't it? So what do we say about that? That is 0.75. So what do we have to write is here for finding the confidence, we can say this support dot count, and here we'll say support of bread, that is dot count. Now you can say, so ma'am, why did you write it this way? See, for confidence, we can say that support dot count, right? Support dot count. If I want to find this support, what I say is support. If I want to find, I need to say that support dot count divided by number of transactions, right? So here, suppose for this one, I can say 3 divided by 8 upon this is 4 divided by 8, right? Support count of bread and milk, that is 3 by 8, and upon what is the support of bread, that is 4 divided by 8, right? So what happens that this 8 gets cancelled, right? And that is why directly people are saying it as support dot count upon support dot bread, right? So we can write it as 3 by 8 upon 4 by 8, right? This is just to explain you. It is the rule, that is support of bread and milk divided by the support of bread, right? Okay. So what do we say over there? That is 0.75. Actually, it is 3 by 8 upon, you can say, we can write it this way. So you can better understand it, right? 4 by 8. Okay. So this is the way we have to use. Fine. So you know how to find the support and confidence. Okay. Now what do we say about the support and confidence? Customer buys both. Customer buys both. That is what you can say is customer buys bread is over here. This black circle say that customer buys bread. Customer buys milk. So it is this orange circle. And if we say that customer buys both, so whatever is the intersection of both, that is the customer buys bread and butter, right? This circle is for single item bread. This is for single item milk. When that is, there is the intersection, we can say customer buys both. Okay. So what is the goal? Given a set of transactions T, the goal of association rule mining is to find all rules having support greater than or equal to minimum support and threshold confidence that is greater than or equal to minimum confidence, right? Minimum support, as we see that it is greater than or equal to, that is whatever support we have found, that is greater than or equal to minimum support. The same way we can say that confidence of that rule is greater than or equal to minimum confidence threshold. Fine. It is greater than or equal to minimum confidence threshold. Fine. So for the same transaction, whatever we were having, say association rules, if we say that bread, jam, milk, milk, jam, bread, milk, jam, bread, milk, and milk, bread, jam. That is the implies is there in between those item sets. So what we need to do is we need to find the count of it. How to find the count? I mean, how to find the support and how to find the confidence. For that, we can say, for support, what do we know is, we need to find the count of these two items in the item transactions. Then what do we say is divided by the total number of transactions. That will give us the support of that rule. For confidence, we can say the count of bread and jam in all the transactions divided by the count of bread in all transactions, right? So that will give us the confidence, isn't it? Now, whether this rule is accepted or not, for that we can say that this support should cross, or you can say it should be greater than or equal to minimum support, and confidence whatever we have found, that should be greater than or equal to the minimum confidence. Okay, so same way you can find the rule. Now you can say that if we want to find the relation between bread, jam and milk, what relation? That is in terms of the association rule. So what should we do? Bread, jam, milk. So only this one rule, that is bread, jam implies milk. Only that we should take? No, it can be having any relation. Like say milk jam implies bread, bread implies milk jam implies bread milk, or milk implies bread and jam, right? So three items are there, and we can check for all these rules which are being mentioned here, right? Then we need to find the support, we need to find the confidence, and then we need to check whether they are greater than or equal to the minimum measure, whatever is given, that is greater than or equal to minimum support and minimum confidence. Support, we will check whether this support what we have calculated is greater than or equal to minimum support or not, and for confidence we will check whether it is greater than or equal to minimum confidence or not. Fine, it is so simple, isn't it? So mining association rules, we are studying all the rules which we have just seen are binary partitions of the same item set, that is milk, bread and jam. Milk, bread and jam, that is all this five. Okay, in that you can say that three items are being considered. They are bread, jam and milk, right? In different sequence, different sequence, that means bread, jam, milk, right? That way, then you can say bread is in the numerator, bread is in the denominator. The sequence is also changed. The sequence is changed. That means you can say that bread jam was there. Now we are having only bread at left hand side and other items at the right hand side. Fine. So this way we can create the rules, and we need to find the support and confidence. Then after we need to check whether they are greater than or equal to minimum support and greater than or equal to minimum confidence or not, for support and confidence respectively. Fine. So what do we say? That the rules which we have just said, they were the rules regarding milk, bread and jam. Rules originating from the same item set have identical support, but 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 can have different confidence. Okay, item set, that means milk, bread and jam is there, but if we say that milk bread implies jam, then you can say jam will be there in the what you can say, this x dot count place, right? In the x dot count place, if we change this item from jam to bread, you can say here it will be y dot count, that is jam dot count was there, Now it can be bread.count, right? So the item is different, right? So count will be different. And so see, here you can say that y support dot count, x support dot count, right? It can be same, but not the same here, because here it is, you can say x and y is available here. Support of x and y is available. So you can see here it is same. That is for support. But for confidence, it contains support divided by x dot count, whatever is the item. Fine. So you can say that it is having same support, but confidence is different. That example I already have shown you, isn't it? Here you can say bread implies milk and jam. Bread implies milk and jam is zero point 0.4 and 0.75. That is support is 0.4 and confidence is 0.75. Now let's see the other item where you can say bread implies milk and jam, right? So if we say that support is zero point 0.4 only, but the confidence by chance here is 0.75. Let us see one more example. This one, jam, bread and milk, same items are there, but the rule now is different. That is, jam implies bread and milk. Support is same. For all these rules, support is same, but the confidence is zero point 0.6 in this case. For other rule, it is zero point 0.5, right? So what I mean to say is, if item set is similar, we can have this support same but not the confidence. Here you can say for first three rules it is having the 0.75, and for other it is zero point 0.6 and zero point 0.5. Okay, so support can be similar if the item set is unique, but confidence may not be, right? So what we should do, that x implies y and y implies x are not same. Okay, we can decouple the support and confidence requirements. Fine. So mining association rules, two-step approach. One is frequent item set generation, that is generate all item set whose support is equal or greater than to the minimum support. Second one is rule generation, generate high confidence rules from frequent item set. Each rule is a binary partitioning of a frequent set. Which set? Item set. Fine. Frequent item set generation is computationally expensive. So what are the applications of association rule mining? They are market basket analysis. Keeping that as the base, we have learned the things, right? This application we are talking of since long. So we can understand that very easily, isn't it? Any concept, if the real world example is there, we can understand it very easily and clearly, isn't it? So for market basket analysis, what do we say? Given a database of customer transactions where each transaction is a set of items, the goal is to find groups of items which are frequently purchased together. Fine. For telecommunication, we can say each customer is a transaction containing the set of phone calls. What do we mean by that? To whom I am calling, right? See, I am calling, so my number is there. To whom I am calling, for that also one number is there. From that, we can have to say country. For example, today, or you can say till date, I was calling the people who are Indian only. And suddenly, If I start calling outside India people, you can say, what's the issue? It is your own choice. Your own card is there. You are paying for that, so no issue. No, we are not talking of that. No issue is there. But from these many years, I was having this general pattern. Now, suddenly it is getting changed. So there can be the fraud also. It is not always the fraud. The change is there. So you need to check it out there. There can be something suspicious that my phone is being hacked and others are using it. Right? So for such thing, the telecommunication industry will give you the notification that till now you were not having the out of India call, but now you are having this many calls, right? So if in case my phone is hacked, I can have the information, I can communicate to the telecommunication department, and then after the hack can be saved, right? That is my data, or you can say people will not be able to use my phone further, right? So we can stop it. Fine. Okay. So we are talking of the in telecommunication also the what association rule mining can be applied. Fine. You are calling. If I am calling to my mama, I'll call my papa also. Right? The rule can be satisfied. Right? Okay. Next application is credit cards banking services. Each card or account is a transaction containing the set of customers' payments. Fine. So based on that, we can have the idea how people are calling. What is the general pattern of it? Right? We can have the association rule in that. Fine. Medical treatments. Each patient is represented as a transaction containing the ordered set of disease. This person is having, say, diabetes. That person can have the pressure also, right? Something like this. Okay. Because it is many times found in the transaction of customers, that is the patients in their records. Fine. Basketball game analysis. Each game is represented as a transaction containing the ordered set of ball passes. Fine. This also you can understand very easily. Now, that's all for today.